morning. Welcome to Mathematicon, a place where mathematics is made easy. On this channel, we shall be expanding on the concepts in the areas in numerical analysis, calculus, statistics, and in the nearest future, we shall be uploading videos on robotics, application of mathematics to robotics. So I encourage you to subscribe, to like, and to comment within our channel. Thank you. Today, we shall be solving examples from the previous class. Last week, we talked about several methods, numerical methods, for solving or determining the root of a simple equations. Equations such as f of x is equals to 0. So today, we shall be taking example using the Newton's method to find the roots of this equation. Thank you. Example 1. Okay. We're going to take f of x to be equals to sine x, and we let our x1 to be equals to 3. From the previous class, we were given that Newton's method has this formula n plus 1 equals to xn minus f of xn divided by f prime xn. So where our fx is given as sine x. So from here, we'll go ahead and find the first derivative of sine x, which will give us cos x. Then we substitute these values into our formula, our Newton's method formula. We have xn plus 1 equals to xn minus sine x over cos x. Now don't forget that we have been given our x1 to be 3. So when n is equals to 0, we have our x1 equals to 3 minus sine x over cos x. Now from here, we'll discover from our trigonometric identity that sine x over cos x is the same thing as our tan x. So the equation is reduced to x1 when n is equals to 1. So the equation is reduced to n x2 is equals to 3 minus tan x. Now it's going to be n xn, xn, and xn. So we have 3 minus tan xn. And in this case, we have taken our n to be 1. So we can rub this n off and replace it by 1. So the equation has been made simple. So from here, we have it to be 3 minus tan, our xn is given as 3, which is equals to 3.142546.543. Now we'll continue in this pattern to determine our x3. Our x3 is given when n is taken as 2. So the equation reduces to x2 minus tan x2 minus tan x2. So here we already found our x2 to be 3.142546.543. So we have x3 to be equals to 3.14546.543 minus tan x2, which is also 3.14546.543. Now, if we simplify this, we are going to have 3.141592653. Now we can continue our x4. Now x4 contained in that pattern, x4 will be given as x3 minus tan x3. And don't forget we've derived our x3 to be 3.14592.653. So it becomes 3.141592653 minus tan 3.141592653. So if we simplify this, we would arrive at 3.141592654. We can go ahead to determine our x5 which will now be x4 minus tan x4, which we have derived in the previous step, our x4 to be 3.141592654. Then subtract from tan 3.141592654. So we can continue on and on and on like this. So simplifying this, we have our x5 to be equal to 3.141592654. So since we have f of, if we calculate it, we are going to have, since we have f of 3.141592655 to be equals to 9.0 times 10 minus 11. We also have f3.1415926545 to be equals to minus 9.1 times 10, 11 less than 0. This is greater than 0. So we would see from here that the solution to the root of this equation, f of x equals to sine x, is given as pi. Because this is very close, you can see we are approaching 3.15. The steps are getting closer and closer. So we can then take that pi must be between 3.141592655 and 3.141592655. Thank you very much. In subsequent class, we shall be expanding and taking another example. Enjoy the rest of the day. Thank you. Good morning, class. This morning, we shall be taking example from the previous class. Last week, we talked about numerical methods for finding the root of simple equations. So this morning, we shall be taking example on Newton's method for finding simple equations. Simple equations such as f of x is equals to 0. So let's take our f of x to be equals to x squared minus 2 and our x1 to be given as 1. So don't forget that the Newton's formula is given as xn minus f of xn over f prime of xn. So the first thing for us to do, given all the parameters, is to find our f prime of x, which is the first derivative of f of x, which is 2x. Then we can substitute all these values into the given formula. Now we take n when n is equals to 1. When n is equals to 1, we have n plus 1, which will be automatically 2, so we can just put 2 here directly. We have x2 will be equals to 1 minus f of x1 divided by f prime of x1, which our x1 has been given as 1 and our f of x is given as x squared minus 2. So we can substitute this into this equation. We have 1 minus x squared minus 2 over 2x. Now because we are considering 1, we could make this one x1, x1. So substituting this value, it's going to be 1 minus 1 squared minus 2 over 2 into brackets 1. And this will give us 3 over 2, which is the same thing as 1.5. Now to get the next step, which is when n is equals to 2, we are going to have x equals to 3, and the formula will change to x2 minus f of x2 divided by the first derivative of x2. Okay, so we calculated in the previous step our x2 to be 1.5. So substituting into this equation, we have 1.5 minus 1.5 squared, minus 2 into brackets, minus 1.5 squared minus 2 over 2 into bracket 1.5. Now, if you evaluate this, we are going to arrive at 17 over 12, which is the same thing as 1.416667. Now, also, to determine our x4, we take our n to be 3, and we have x4 equals to x2 minus f prime of x3, over f prime of x3. Okay. Now, from here we can equally substitute the value, having that our x3 is given by this value. So we have 1.416667 minus 1.416667 squared minus 2 all over 2 into bracket 1.416667. Then if we evaluate this, we are going to have 1.41426. Now, if we continue like this, we'll keep having a closer value to what is written on the board. And this is to let us know that the roots of this equation is given as, because it's equivalent to root 2. Thank you.